Second time.
Hey.
Okay. So you can see it.
Yep.
Yes. Yeah, we see it. It's great.
Okay. Good. Hi. Yeah, I will give a update for the WAMR community, and since
Hang on a second.
Hey, everybody. You're welcome. Hey, everybody. We got a presentation starting. Can you sit down?
Yeah.
We'd love to hear this.
All right.
okay.
So our next presentation is going to be by Cadence, and it's going to be an update on the WAMR community. Thanks so much for making it at, I believe, 7 a.m. your time. So without further ado, please give it up for Xin.
Okay, thank you. Yeah, I will give us update for the WAMR community for all the work in 2024. There are a few agendas. Firstly, give a progress update for the feature development, and I will share two use cases related to WAMR. Those are from the community users. Previously, I planned to share one use case internally by Intel product, but I didn't get approval for disclosure, so I removed that from the list, and also share the customer requirements for future development. Current WAMR is still most of the use cases are still on the core module level, and still so when you really use a WebAssembly to build a product beyond the browser, they still have many challenges. Many are from the engineering and also development productivity perspective. Here are a list of the finished features. So still the major contributors for WAMR are from Sony, Amazon, Siemens, Intel, and Xiaomi. They implemented the multi-module for LOT and enabled WASI libc for Windows platform. Siemens implemented exception handling for the classic interpreter, and enabled the ahead of time compilation Linux perf support for generate the flame graph, and the GC update for the latest Wasm spec. Implemented memory 64 for the classic interpreter and ahead of time. The multi-memory feature for classic interpreter, and also we continue to work on some backend for the WASI, such as OpenVINO, and also on the more kind of source debugger support for ahead of time mode. So typically the usage for WAMR is an interpreter and also ahead of time compilation. This is the most used mode. And a few items are still working in progress. Implement core module dynamic linking, and also the exception handling spec has changed. So Siemens team is working on the updated implementation. And the shared heap feature is required by the products that use WAMR. So Xiaomi and Intel are doing runtime internal implementation for that requirement. And the multi-memory for fast interpret and ahead of time, and the more kind of functionality support for ahead of time source debugger. Here is one use case with WAMR. So they compile the TypeScript to WebAssembly and build user interface application for the devices. Here you can see this is a demo. The whole user interface application is written in TypeScript and compile it to WebAssembly and then run it. Run it on small devices. The reason for that is people for such device they currently mostly use QuickJS for supporting JavaScript based application programming. They want a smaller footprint and higher execution performance. So if they change the front end programming language from JavaScript to TypeScript, that is fine, can be accepted by the front end development. Then they can leverage all the type information from the TypeScript to do static compilation to WebAssembly. But why they are more interested in compile TypeScript than assembly script? There are a few reasons for that. Firstly, using the latest Wasm they will have a much smaller WebAssembly binary size. So that's really important for the such devices. And also for some, particularly for the user interface programming, there's many frameworks. All the front end developers are used to develop or develop on that. So they need some dynamic feature to construct all the user interface kind of framework. So we can still support some dynamic language features of TypeScript, so like the any type object. There is a open source project called Wasm neither -ts for compiling the TypeScript to the WebAssembly, and here is a benchmark data. So they compared WAMR fast interpreter with QuickJS. So you can see for most of the classic based programming model, because the type are certain during compilation, so they have a leading performance on WAMR against QuickJS, and they use some runtime extension to support the interface and some dynamic features, and those features are so the performance are slower on WAMR compared to QuickJS. Here's another use case using WAMR, Alibaba microservice gateway. So they currently use V8 as the default engine for the gateway. So the Highgrass is some product built on top of a Envoy proxy. So firstly, they leverage the WAMR ahead of time compilation to get much better performance in their system. We provided some enhancement for their production need, particularly for the observation demand, such as CPU flame graphs and enhanced core stack dump and performance collection for the Watson functions. And also, they are they want to provide some LLM, large language model support in their system, and so we kind of worked together with them, evaluate how to build such kind of capability with a WebAssembly, and YZN is a really a natural kind of a recommendation, and from us. The current the issue from the product team is their customer really want to use Python as the primary programming language, and they want to see if any possibility to compile the Python to plug in WebAssembly and load it in this system. So we did some work with the open source project. I remember that Nuika, and I think another project, WASMA team already submitted some patches, and we continued to submit some patches. And basically it can be working, but it's not guaranteed all the Python programs can be compiled successfully yet. So there are still a long way to go if we want to provide Python support. Here is some really related to WebAssembly, not really related to Bytecode Alliance, just for your information purpose. Thanks for David, Nick, and Bailey to give such agreement to show that in this meeting. These are two open source projects we are involved. The first one is a Wasmtime TLS to toolchain to compile TypeScript to WebAssembly GC, and another one is a Wasm to native. This is a toolchain for compile the WebAssembly to just to native library. So this is something inspired from the Google another Google open source project to compile the Google Android native module to WebAssembly, so that make those native modules can be platform independent. Okay. Okay. the last page is about some requirement for the future development. There are quite a few large companies are building some products with WAMR, and the most common usage is a device related. Device development is quite different with cloud development because the whole development is predefined and mostly a restrict schedule, so you don't have much flexibility from software perspective. Like if your software solution can't meet one single requirement, then the software solution must be changed. So sometimes the WebAssembly can meet most of the requirement and bring really unique value to such product, but still can't meet all the requirement. So in such situation, they just can't wait you can get a solution from standard change. So you need because the timeline requirement. So the first one is a shared memory among multiple WebAssembly instances. A typical usage is in the device, like you have a camera, you want to continuously process the image captured by the camera, and you probably have a multiple modules for different kind of processing algorithms, and for small device, they don't have enough memory or enough CPU to make the memory copy among different instances. So they want to share the single frame buffer. The current the isolation by linear memory. So this is a challenge, and yeah, so that's why you are seeing in the WAMR community, both Xiaomi and Intel are implement a feature called a shared memory, shared heap. And another significant problem is the effort to create wrapper functions. So there are a lot of the product related API defined and exposed to the WebAssembly apps, like the demo I showed, the watch with a user interface. Actually, there are hundreds of functions to be wrapped by native function to be wrapped to the and exported to the WebAssembly. This is really a big effort and very easy to make a mistake. So that's a problem for engineering, and we want to see if we can really get some support for that. Maybe some tools, maybe we can go to some help from the Wuyts kind of approach, Wuyts definition approach, but it's really not. We have not done much for that really yet. Also, the development productivity, particularly for the host and the guest are both in C++. So like use the watch user interface demo So we just showed the low-level framework for the user interface is LVGL, and they have a library and all the function and the header files defined, and there are some existing C applications, C code that using the LVGL API. So we want to see if it is possible to don't do so many wrappers for all the library functions, so can smoothly compile the existing C application to WebAssembly and run it on top of the um, uh, mm, low-level library in native kind of mode. Also, another use case is a CHRE, which is a sensor hub context framework for the Android, and one community user actually are building the CHRE apps from native to WebAssembly. So this is a similar situation because the whole framework is programmed in C++, and it would be ideal if existing C++ based apps can be compiled to WebAssembly, just run it on the framework. Also, the next one is the stack switching and even possibility of runtime assistant scheduling. In some small device, so for sure we can use the multi-threading for multitasks. But for some small device, so if we can use don't need kind of multi-threading, just give the apps ability to kind of simulated multi-threading, so do the stack switching, and even if we can let the runtime to kind of do some uh, pick some kind of a kernel kernel's job to assist the scheduling, like time check and doing the stack switching. That is really useful. Also, checkpoint and restore. There's I think is some so that means so during the execution, the whole execution of a WebAssembly can be switched to another environment or another device. So continued to run from next code line. This is really useful for the device availability, high availability. And there is a PR in the WAMR community is is done by university students, and but that PR is really large, and we have not finished review the code yet. Is a big change to the code structure. Okay, that's all update from me today. Thank you for your patience.